Parashar, ENAE380 student. This is the 12th month, 15th day, 2025. And my coding project or my final project was making a weight and balance calculator for small single engine aircrafts, like often used for student pilots in training in flight schools, such as Cessna 172s, Piper Cherokee Archer, and so on and so forth. However, for this specific project, I've only acquired two specific aircrafts because for each aircraft, the weight and balance and the POHs are completely different. So this calculator is specifically just for Cessna 172 and Piper Cherokee Archer. In future runs, I potentially may add more and more aircrafts in here. We're doing more research in the POHs and the FAR aim that helps us get all the data basically. So um when I start with all the libraries basically, at the top of the file here, I imported standard Python libraries. I use data classes to define structured data for aircrafts and stations, and typing to make functions inputs and outputs clearer. I intentionally avoided external libraries so the program runs clearly in Spider. So I basically like made sure like when I run this, I don't need to use any new plugins. I don't need to have Streamlit to make an app or a website. I was thinking to do that, but it was adding so many libraries and plugins, and I had to like use Anaconda prompt. So I just made it very concise so that it's easy for the user to be able to use the calculator without having any problem. So that's why I kept it all in the terminal, even the graphs that I made, kept them all in the terminal. So here we have station. So in station, like each station represents a physical loading location in the aircraft, such as like fuel, baggage, stores in the arm in inches. So inches mercury is what I'm using, inches, sorry, not mercury. And I made the class frozen so that station geometry can't be accidentally modified during calculations. So that is station aircraft. So I made another class named aircraft, and here I'm storing all the aircraft specific data, like including the empty weight, the moment weight limit, station definitions, and CG envelope. The CG envelope is stored as a list of tuples where each tuple contains the weight and the corresponding forward and aft CG limit. So as you can see here, these are all the floats, and then this is the math that I'm doing to do linear interpolation, finding the exact match, and when we do the math, it forwards it back to the function, so it stores the values. Aircraft builder here, I'm, you know, what is it called? I'm storing the data and the information again. So what this is doing, it is asking, is computing the moment from weight and arm. So again, the math, and it's adding all the information in. So here we have the model, says Naskahawk, and I made sure to include this for educational purposes only, just because uh, I'm using POHs from specific aircrafts, and if someone uses this with an aircraft that has different like compartments inside the fuselage, like the two seats missing or something like that, then this would not work. This only works with a default Cessna Piper aircraft. So I also made functions to compute the allowable forward and aft CG limits for a given weight. If the weight falls between two envelope points, I use linear interpolation, like I said earlier. Here, this is the math. If the weight is outside the defined envelope range, the function returns none, which forces the program to treat the configuration unsafe. That's the main gist here. Um, then this is just again, I made a station, I made like a library, adding all the baggage stuff, all that stuff with all the arms that I got from the POHs. Aircraft, again, more libraries. I used a lot of libraries in this. And let's continue, keep going here. So this is for the Archer, exactly, and this is for the Cessna, by the way, just to like make it exact. Sorry, I'm all over the place, but I've been working on this a lot. So yeah, so this is the information stored basically for Cessna, and this is stored for Piper Cherokee Archer, for example. Now when we go down to prompt flow, this is what I'm prompting the user. So the user has to input all the values. So if you can see, I'm saying I'm saying prompt the user for a float point number with validation. So I'm basically requesting the user to give me an input. Based on the input, I'm gonna ask. The calculation is gonna be done in the back, And if they do any wrong input, then all these will help. So the value cannot be zero, please try again. If they give me a zero value, value must be at least minimum value, please try again. Value must be at most max value, please try again. And then invalid. So this is just basically troubleshooting, making sure that they don't give me any invalid value, any wrong value, any unjust value, and no false assumptions are being made. Then you have prompt yes no. So prompt yes no question and return true for yes and false for no. So this is just a true and false statement. I use this a lot in this code, but mainly I use this for additional fuel and additional fuel burn, because that really matters. In the beginning of my code, I did not really account for that, but once I started going like deeper, I realized that that's also a major factor, and that my calculations were absolutely wrong if I don't add that in there. So I request this as an option, the user to whether they want the calculation in or not. Then I ask the user to select the aircraft. So this is just a function I made to select the aircraft, and I made sure that it prints if they don't give me one or two as a value, it prints invalid selection, please enter one or two. So basically just saying to print it again because you give me the wrong value, and then you're choosing aircraft here. Here is a core calculations, all the nitty gritty actual calculations that are done for the moment, CG, and arms and weight. So here we're computing all the total weight for the aircrafts, given all the loads that they just inputted, and this is the CG total. This is the given envelope. This is the whether it's within the envelope or not, and this is the limits, basically limits of the limits defined, and then this is what checks the limits and then prints it. So it checks limits, prints the limits. So here you have the print. We have printing the aircraft, the thing inside the graph and stuff. So ramp weight informational check. Here I'm making sure that the ramp weight is greater than the aircraft's max ramp weight, because if the ramp weight is greater than the aircraft's max ramp weight, then it's not good. So then I would have to print that it exceeds the max ramp weight. So these are just doing the checks and balances basically here in the code. Like I can go step by step, but it's just like a checks and balance to make sure that they don't give me a max weight way more than what's allowable. For the ramp weight, takeoff weight, again, if the takeoff weight exceeds the max takeoff, then I'll tell them that it exceeds. If it doesn't, it does not. So then we keep going. That's just basically what this is. This is just checks and balances again. Then we go to the max additional weight. So this is the part that matters the most, because for pilots, they can calculate the amount of CG, the aft CG, the forward CG, but the problem is they don't know how much more to add to still stay inside the limit if they want max performance from the aircraft. Because sometimes we try to get as much pound in versus the obviously aerodynamic principles, like aerodynamic like stability and all that for the aircraft. So you might have it on and you might have a little bit more space, but the pilots usually don't know that unless they calculate it. So I make it easier to let that can make the calculations also be part of the calculator, so that they don't have to do anything, that they can just do the calculations. So that's what here was happening here. So I'm building a takeoff condition by subtracting taxi fuel from ramp fuel, and I subtract taxi fuel as a part of the current loads at a fuel station. The caller should provide taxi fuel in pounds consistent with current loads, basically the loads that are already given for fuel. If they've already given 20, they can't just give me 40 for takeoff fuel. That wouldn't make sense, because the aircraft's max fuel would also you know they would break that limit. So that is that here. Um, this again checks the limits. So it's a silent version of limit checks for the internal computation of all the math and everything going on. Then I am printing the loading. So this is just reporting. So this prints a formatted weight and balance report and returns takeoff weight, takeoff moment, takeoff CG. Basically, that's what this part is. So printing, 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 empty CG, aircraft, blah blah blah. This is just printing the stuff inside the terminal, and instead of just relying on a graph that I make using some plugins or using additional libraries, I just resulted in making a graph inside the terminal, because no matter where you run it on any software, this will run and it will be totally fine. So here I make the ASCII graph. So I make sure to use the right bounds and everything. This is just again doing that. So min w, that's minus, minus equal w margin, blah blah blah. rows, columns, just going through, and I'll show you what this basically does inside the terminal as well at the end. So this is just basically printing the graph here, and this is plotting the current points on that graph. User input collection. So here is basically gonna print enter loading information, blah blah blah. This is like the beginning, the stuff I want. Pilot plus this, and then the minimum value starts at 0, and then when they input the thing, the information, it will change, and so on and so forth. Fuel, avgas approximation. So I'm using 6. I know that in some POH is 6.6, but just for approximation, I'm using 6. This is again just printing in the main function the beginning of the code, like a weight balance calculator for these two. Know that it's only for educational purposes, always refer to the official POH for real flights. Then you have ramp weight, which is this. Print report copy. This is all printing stuff again. Graph is for takeoff conditions. And yeah, and that is it. So now, and this again is a takeoff load condition is within the limits, blah blah. So if it's in the limits, then it will print this stuff. If it's not in the limit, it will print this, exceeds the maximum limit. So this is all just if statements to make sure that the calculator is safe and it checks every scenario and is not just messing someone up. So now I'm gonna show you how it works in the terminal. So it's gonna first ask which aircraft you want to choose, Cessna or Piper. I'm gonna just choose Cessna. Now it's saying that the aircraft I selected was Cessna for educational purposes. Enter the loading information. All weights are in pounds. I make sure I specifically say that, except fuel, which is entered in gallons. Enter 0 for any station not used. So for pilot and co-pilot, let me just put 200 pounds. I know it's unrealistic, but just to give you an example, rear passenger total, let's just give it 200 pounds as well. Fuel, let's give it 15 pounds of fuel. Baggage, let's say 0 and 0. And max, do you want account for taxi fuel burn before takeoff? I'll say yes because it matters. But I do keep it as an optional just in case people don't really care about it. So let's say 2 gallons is burned. So now this is gonna give the full report. So here it's gonna give you the entire table, like I said, of the weight, arm, and the moment. It's gonna give us the ramp total, the taxi fuel that's burned at this arm, the takeoff total, which is giving you the values, and then the limit checks, like we said we saw in the code, right? So the max ramp weight is this, the max takeoff weight is this, the ramp weight is within maximum ramp weight, and the takeoff weight is within maximum takeoff weight. So this is again, this statement is a print statement that came from if statements to make sure that this aligns with this. So that is what matters. Takeoff and ramp. Since the max ramp weight is this and the max takeoff weight is this, these two values here are within these two values. So then it prints this. That's basically what that code was doing above. Then it shows you the takeoff CG, the forward CG, aft CG. CG is within the limits at takeoff. So again, the takeoff CG, the aft CG, it checks it. Just like we just checked the weight is within the limits, we also check if the CG is within the limits. So everything needs to be checked for the pilot. This is not a joke because people can literally die and from stalls. So first we checked here the takeoff and ramp weight, and now we check the CG. We see that the CG, the aft and the forward CG, which is here, is within the limits. So it says it's within the takeoff limits. Now this is the graph that I generated, is the ACCIG graph versus a weight graph. Takeoff condition, obviously. Envelope. This is the envelope, and this is inches, and this is in pounds. Weight versus the arm, and we see the X, meaning we are inside. So if this X was outside here somewhere, then we would not be inside the limit. So I'll show you both cases. This is just the case to show that it's inside the limit. So the overall safety summary takeoff condition here, it's going to give you as well. The takeoff loading condition is within the limit. So now it's checked for everything. It's within the limits. The maximum additional weight while remaining within limits is also this. So now I've given also how much additional weight they can add depending on whether they want to add additional weight or not. So this depends on where weight is added for sure 100%, and results below. All added weight remains on board at takeoff. So fuel could be added up to 400 pounds. Um, Pilots and co-pilots 400 pounds could be added. Rear passengers 382 pounds. Baggage and this can be also added. And now I'm not saying that you can add all these total. I'm saying that these for the configuration that the pilot chose here with all the information he added already 200 200 and giving the fuel 15 and 2 burn for the taxi fuel, these are the additional that they can add individually. So they can add 400 pounds of extra fuel now. That's max that they can add. They can add 400 pounds of pilot plus co-pilot. That's it. They can add rear passengers, baggage, and baggage area too, basically individually. So that's it. And it says for fuel, the valuation above is in pounds to convert gallons divided by 6 avgas approximation. So I just make that clear because I am doing it in pounds. You can do it in gallons, but this is better for the user to know, and so that like it makes it clearer. Now I'm gonna show you a way. I'm gonna show you what it shows when the things are not in the limit. So let's run this again, and let's choose Cessna one more time. Let's say for pilots we put 500 pounds. For passengers we put 500 pounds. For fuel we put 30 pounds. And for baggage we put 20 pounds, 20 pounds. And let's say yes. And we're burning 3 gallons. All right. So as you can see, the X is outside the graph. So that means that we're not in the limits, right? So do the same thing again. We put the inputs here. And the weight and balance calculator does the report. Shows the weight, arm moment, ramp total, taxi fuel burn, takeoff total, and then it does the checks. So here, the ramp weight and the takeoff weight exceeds by this much. So it also shows how much it exceeds. If it's in the limits, it's within the limits. But the code is also going to show how much it's off by because that's really important. If we know how much it's off by, we can get rid of that much weight from the aircraft without having to do any math. This is a lot of extra math that pilots have to do just to make sure we're within the limits. So now we know that they're 325 pounds within exceeding the limit. So they can take that out and make it safer. 315 pounds takeoff weight exceeds. So they can take that off either as well. So CG limits are not defined for this takeoff weight outside the envelope weight range. So I make sure I mention that. And this is the graph. And then at the end, we give an overall safety summary. And we say that the takeoff loading condition is not within the limits and the CG limits. The takeoff weight exceeds maximum takeoff weight by 315 pounds, and the takeoff weight is outside the defined CG envelope weight range. And that's it. This helps pilots ensure that they fly safely, and it's a CG moment, weight, aft takeoff, forward CG, additional fuel, additional load, how much more load can be added calculator. Basically calculates everything, every math and nitty-gritty thing that's needed for a Cessna and a Piper. I hope you liked my video. I tried to make it as thorough as possible. Um, but yes, this is basically what this is. To give a more generalized summary, I would say that the main function of the program is it's a program flow. So it handles aircraft selection, collects user inputs, calls the computation functions, and prints the final report and summary. All users' inputs validated using helper functions. Invalid or negative inputs are rejected, which prevents runtime errors and ensures physical meaningful results. The graph section generates a ASCII CG where it says weight plot. The envelope is drawn using dots, and the current takeoff condition is marked with an X. This avoids external plotting libraries and working cleanly in Spider. The function uh, max additional weight at station um, computes how much additional weight can be added, specific specific stations while remaining safe. The idea is that the CG depends on where weight is added, so not just how much it is. The function incrementally adds weight at one station at a time, recomputes takeoff CG, and stops when a limit is violated. That's basically the general summary of it. The program checks maximum ramp weight, maximum takeoff weight, and whether the takeoff CG lies within the interpolated envelope limits. If any condition fails, the configuration is reported as unsafe along with a diagnostic message. And the ramp to takeoff conditions, taxi fuel is subtracted at a fuel station arm. So Both weight and moment change consistently. All CG checks are performed using a takeoff condition since that is the safe critical phase. The function compute total weight and moment computes basically total weight and moment. So for each station, like I said in the beginning, the moment is calculated as weight times arm. The total CG is computed as total weight divided by total moment divided by total weight, which directly follows the static equations using the aerospace engineering. And that is it. I hope you liked my presentation. I try to explain the classes, the libraries that I used, the data sets I used, the tuples, as thorough as possible. Now, I could go through the code as well, but I think that's a pretty good understanding. Um, like max weight, I'm getting these from the foreign, the POHs, making libraries and setting the arms in there because we need the arms to calculate the moments, and these are all assumptions. Now, what I could add in retrospect in this presentation or in this calculator is missing arms. So another thing the pilots have to do is calculate how much arm they would need to have max takeoff or max ramp weight. So that could be another implication I could add, and based on that, I can see how much total weight we want to add. So that is another thing, but yes, that's it. I hope you like my presentation. This is Mana Parashar, and this is my weight and balance calculator for uh, Cessna 172 Skyhawks and Piper PA Cherokee Archer.